and welcome back to another Miss Pollard Math YouTube video. Today we are going to be going over completing the square. As always, it's important to know what our steps are to complete the square. So our first step is to take the b value and divide it by 2. Then once we get that, we take our b divided by 2 and we square it. Then we're going to put that as our new c value, and then we are going to put it in our factored form. So our factored form is going to be x plus our b over 2 squared. So we have to remember what our b over 2 is. We also need to know, why are we completing the square? Completing the square is a way to factor an equation. We have it in the form of x squared plus bx, and in general we can factor that way. So these are different ways to solve our quadratics, to get our zeros, to get our solutions. Down here we can see that our formula is going to be x squared plus bx plus b over 2 squared equals x plus our b over 2 squared. So this is something we have to have memorized. Take our b divided by 2, square it, add it, and then we are going to factor form it and put it as x plus our b over 2. Let's look at an example problem to see how we would complete these problems. So here we have an example problem. We have n squared minus 20n plus 33 equals negative 2. And we want to factor this by completing the square. So let's take a look. Every single time we only want our a and our b term on our left-hand side. So we're going to subtract over our c term to get a new d term. So I have n squared minus 20n equals, when we put these together, that's negative 35. Now, we're going to follow our rules. Where we take our b, we divide it by 2. Our b is negative 20, so I'm going to put this over here. Negative 20 divided by 2 is negative 10. So I'm going to recall later that this is my b over 2. And I'm going to box it off so I remember that for later. So I took my b divided by 2. Our next step is to square it. So we have negative 10 squared. Negative 10 times negative 10 is 100. So this becomes n squared minus 20n plus 100 equals negative 35 plus 100. I'm going to put this in my calculator just so we know I'm 100% correct. And this side becomes 65. So now we have a perfect square trinomial on that left-hand side, and we want to be able to put it in our factored form. So our factor form says we take our parenthesis, we take our variable, and then we take our b divided by our 2. I've boxed this off. My b divided by 2 is my negative 10. So I have minus 10 squared. Now we're going to continue in something that we saw before. Before we did completing the square, we did solving quadratics using square roots. So this is where that's going to come into play. So if we're not as strong on that, this is going to be a little bit of a challenge. But let's see how we would continue this problem using our square roots. So we can't add the 10 over. There's nothing else we can do on the inside there. We have to get rid of that square. So to get rid of the square, we square root both sides. And I get n minus 10 equals, when we square root something, that's the positive and negative square roots. So that's going to be positive or negative square root of 65. Now I don't want n minus 10, I just want n. So I am going to add 10 over, and I get n equals 10 plus or minus the square root of 65. Some teachers are okay with you leaving it just like that. However, I like for my students to put it in decimal form. So you're going to put in your calculator 10 plus the square root of 65. And we have to put those approximation symbols. It's not exactly this number because we're going to round it. So I'm going to get 18.06. I chose 2 decimal places. And then we're going to do 10 minus the square root of 65. And I get, or it could be 1.94, we can say. So these are my 2 answers. These are my 2 solutions, my 2 zeros, my 2 x-intercepts. There's many ways of what we can call it, but those would be the solutions to these problems. Let's try another problem, make sure that we are understanding this concept. So now we have this problem, 14a squared minus 1 equals 8a plus 10a squared. And what we want to do is get all the terms on their correct sides, on the sides where this would make my life a little easier. So I want my a squared to be on the left-hand side, so I'm going to subtract 10a squared over, and this becomes 4a squared I want my 8a on this side, so I'm going to subtract 8a over, and I have that. I want my constant term to always be on my right-hand side when I am doing my completing the square, so I'm going to add 1 over to the other side. So all this looks a little bit weird, but this is just so it goes on the other side, and I combined it here. These couldn't combine with anything, so I just moved it over. Now, this is where we get into a little bit of a problem because we cannot have a coefficient for our a term. I know I'm saying a and there's an a squared, but 4 technically is our a value. That's our a value of a quadratic. Our a value of quadratic must be 1 for us to be able to complete the square. So what I'm going to do is divide each term by 4, so my a term, my a value is 1. So I'm going to divide by 4, and my new equation is going to be a squared minus 2a equals 1/4. And it's okay to have fractions. That's totally all right. So now I'm going to do what I did before, where I take my b and divide it by 2. My b here is -2. So I do -2 divided by 2, which is -1. So my b divided by 2 is -1. And I box that off so I remember that's what I'm going to need at the end of this process. Once I get my b divided by 2, which is -1, I want to square that. So -1 squared, -1 times -1 is +1. So on this side, it becomes a squared minus 2a plus 1. On the other side, we have to add 1 as well. So if I add 1 to this side, that's the same thing as adding 4 divided by 4. So I'm going to do equals 1/4 plus 4/4, just so I can easily combine those terms. I know on my left-hand side, that is going to become my variable. We have a minus here, so minus our b over 2, which is the -1 squared, equals, add these together, this becomes 5/4. So I have a minus 1 squared equals 5/4. Once we get here, once again, we're going to use our square roots. So I'm going to square root both sides, and I get a minus 1 equals plus or minus the square root of 5/4. We can put this as a decimal if we want. 5/4 is going to be 1.25. Now I add 1 to both sides, and I'm going to have a equals 1 plus or minus the square root of 5/4. Let's put that in our calculator. We do 1 plus the square root of 5 divided by 4, and I get a is approximately, that's an approximation symbol, not an x. A lot of my students think this kind of looks like an x. That's approximation. 2.12 we can say, or 1 minus the square root of 5/4, which is -0.12. So those would be my 2 answers. This is very important that we're getting everything on its proper side. We are dividing by our 4 because we can only have an a value equaling 1 to be able to complete this problem. Let's look at a problem where we're going to have to put an equation from standard form into vertex form using completing the square. So we have y equals -2x squared plus 20x minus 52. And this is our standard quadratic equation. We want to put it into vertex form using completing the square. So every time we have this type of problem, just like we did before with completing the squares, we want to get that constant on the other side. So I'm going to add 52 over, and I get y plus 52 equals the -2x squared plus 20x. Now this is where it's going to be a little bit different from when we did completing the square regularly, because normally we would just divide everything by 2 and continue. But the issue is if I'm dividing the right-hand side by -2, I have to divide the left-hand side. But we don't want y divided by 2, or -2 in this case. That's a little strange. So what we're going to do is factor out that -2 from the right-hand side. Keep it there, so we know we're going to be applying it later. And that's exactly what we do in vertex form. We have our a term on the outside of the parentheses, so that's just what we're doing now. So I'm going to factor out that -2. So -2 parentheses, I'm left with x squared minus 10x, and then we would end the parentheses there. I moved it over a little bit because I'm going to complete the square and fill that portion in. If you want to leave that space, you can. If not, you just write another step down. So now I take what's inside my parentheses and I'm going to complete the square. So I have -10 divided by 2 as my b divided by 2. So -10 divided by 2 is -5. And that's going to be my b over 2. Let's keep that there for my memory log. Now, we always do b divided by 2 and then we square it. So -5 squared, once again, negative times a negative is a positive. So -5 times -5 is positive 25. So I'm putting plus 25 over here. One major mistake that so many people make is saying, okay, if I'm adding 25 to this side, just like I did when I completed the square, I'm going to add 25 to this side as well. Incorrect. The reason that's incorrect is because we're not just adding 25 to this side. We are adding -2 times the 25. So the key point here is to put it inside the parentheses. Put it in there. So we know to do -2 times our 25 to have that balanced equation. So what is -2 times 25? That is -50. So I am going to add a -50 onto this side. I'll just put it down here. So that becomes y plus 2 equals -2. I'm going to put this in my factored form. My factored form, once again, is my parenthesis, my variable, and then my b divided by 2. My b divided by 2 is -5, so I'm going to put that there with my square. Finally, one last step. We want this in our vertex form. Our vertex form just has y by itself on this left-hand side, so I'm going to subtract over the 2. And I get y equals -2, x minus 5 squared minus 2. And that would be my equation in vertex form. However, it also asks, give the vertex as well. So my vertex, as we can recall from our quadratics unit, when we're trying to find the vertex in vertex form, is the opposite sign of inside the parentheses, which is 5, and the same sign for our y. So my vertex is going to be 5, -2. I hope with all these type of problems, we're able to see how to complete the square when our a is 1, when our a is not 1, but also how to find the vertex form of a standard quadratic equation and using completing the square method.